Hello and welcome to this month's special edition of Technology Update, where we look to the skies to see the peak of Russian innovation. On today's show, we catch a glimpse of Russia's latest stealth fighter. We find out that a cross between a battery and a combustion engine isn't just a load of hot air. And down on the ground, we learn about the mysterious nightshade. But first, let's take a look at some of the highlights of this month's MAKS Air Show. The International Aviation and Space Show, or MAKS, is the highlight of the calendar, not just for aviation enthusiasts, but for anyone who enjoys a good day out. The air show started off in 1993, where the focus was mainly on entertainment. Since then, it's evolved into an important business event, giving the high flyers of the aviation industry a chance to sell their wares. This year, MAKS smashed its own attendance record, with over 150,000 people braving the elements to visit the event in just one day. Business also boomed, with companies signing agreements and contracts worth $21.2 billion, which is significantly more than last time. But the event has wider implications than just the aviation industry.
The aircraft manufacturing industry always drives innovation throughout the world, because to be competitive in this industry, you have to excel in a number of different areas. That's why this industry receives so much investment. Some people say that for every ruble invested in new technologies for aircraft manufacturing, you get a return of 7 rubles because of the positive effect this provides for all the other industries.
I'm sure that return on investment was the last thing on people's mind when the flight program started. As well as wowing the crowds, the demonstrations give manufacturers the opportunity to show off exactly what their aircraft can do. This is especially important for military aircraft, and MAKS is the perfect place for defense organizations to cooperate.
The Mi-8 is the most efficient helicopter in its class. And the fact that the US has purchased these machines for its operations in Afghanistan is testament to this. This is a low-maintenance helicopter that works well in very difficult conditions.
But MAKS isn't just for selling military hardware. This Mi-171A2 civil helicopter builds on the legacy of its armed counterpart, the Mi-8, and is about 30% cheaper than anything else on the market. And the peaceful international cooperation doesn't end there. Company Russian Helicopters presented the first prototype of its luxurious Ka-62 passenger helicopter. The helicopter is fitted with French engines, marking the first time the company has teamed up with a European partner. It's still undergoing ground tests, but the company has already received a number of orders. And of course, no MAKS Air Show would be complete without a display from the Striji and Ruskiye Vityazi aerobatic teams. The two groups have been showing off their precise flying skills together for over 10 years. But they weren't the only ones with some slick moves. Seeing the grace and agility of bulky passenger jets as they performed seemingly impossible maneuvers for such large aircraft would be enough to cure anyone of their fear of flying. But I doubt you'd find many people willing to take to the air in this contraption. You'd be forgiven for thinking that all the action was taking place outside. As well as providing shelter from the inclement weather, the pavilions also gave visitors of all ages an insight into the high technology that keeps the aircraft in the skies. Irkut also seized the opportunity to show the future of aviation with its MS-21. The medium-range jet is due to hit the market in 2017. It will be built with composite and alloy materials and economic engines which make it greener, while the wider cabin makes it more comfortable for those inside. The MS-21 airliner is the first Russian civil aircraft to be built fully around the open architecture principle. This means that components and systems can simply be swapped out if they need repairing or upgrading. The company also demonstrated the simulator for the aircraft. The fixed base device emulates the controls and avionics of the MS-21 and can also be used to test out possible modifications to the plane. It was designed by Russia's CKT company and Dutch company Sim Industries, and will also be used for Irkut's pilot training program. And talking of training pilots, this Yak-130 is capable of simulating the feel of flying 4th and 5th generation jets. It is also extremely difficult to get into a flat spin, but if the rookie pilot somehow manages it, the Yak will take over and save the day. It is even capable of landing on unprepared airstrips. It's not surprising it was voted the best trainer at the Paris Air Show this year. MAKS isn't just a place to showcase aircraft, and one of the highlights of the show this year was this space capsule prototype by RSC Energia. The capsule is part of a next-generation spaceship that will serve the International Space Station and possibly even go beyond. The spaceship will be bigger than the Soyuz ships, making it more comfortable for the cosmonauts inside.
This is such a complex piece of technology that there are only 2 countries in the world that are capable of producing it. And even they do this only once every 50 years. We did our best to keep all the equipment here as compact as possible, to leave more room for the cosmonauts, so they can stand here without having to stoop. This is important. For example, similar vehicles produced in the US don't have enough room to stand up in. This is a multi-purpose vehicle that can be used both for taking cosmonauts into orbit and for traveling to the moon.
All of the aircraft at MAKS are on display for everyone to see up close, with the exception of one, because the stealthy design of this next jet makes it very hard to detect. The pakar, or T-50, is Russia's 5th generation fighter. The supersonic jet made its second appearance at the MAKS Air Show, but this was the first time that the media were able to get a slightly closer look. The aircraft is radically different from its predecessors. As well as being faster, more intelligent and maneuverable, scientists have worked hard to make it as stealthy as possible.
The Design Bureau, which is part of the United Aircraft Corporation, works very closely with various research centers of the Russian Academy of Sciences. For example, we've been working together on this 5th generation fighter jet. And I believe produce something that is on a par with the best models in this class worldwide.
The pakar is the embodiment of the fusion between theoretical science and practical application, and is one of only a few 5th generation fighters in the world.
We've got competition from China, and Japan has also announced that it's going to develop its own 5th generation fighter. But so far, neither China nor Japan have presented any working prototypes of their aircraft. So the only jet that can be compared to the T-50 is the F-22. Generally speaking, these 2 planes have a lot in common, but only time will show in what way one is better than the other.
The pakar is a stealth aircraft. Particular attention has been paid to the leading edge of the wings, which has been staggered, the weapons bays, which have been concealed, the jet turbine blades, which have been covered, and the air intake, which is S-shaped. And those are just the bits we can see with the naked eye. The plane must also be shielded from external interference, whilst also emitting signals of its own without being detected. With military planes being so well protected against electronic interference, I bet the pilots don't have to turn off their mobile phones when taking off and landing. Military conflicts often act as a catalyst for scientific advancement. This is especially true of the radar, which first proved itself as a viable means of anti-aircraft defence at the end of the Second World War. Since then, radar and plane developers have been trying to outmaneuver each other to get the upper hand on the battlefield. A simple radar system is made up of a transmitter and a receiver. The transmitter emits radio waves, which bounce off an object, such as this aircraft, and are picked up by the receiver. Military radars can broadly be split into 2 types: detection and search, and targeting radars. Detection and search radars scan a wide area once every 15 to 30 seconds and operate on long radio waves. They are used for early warning systems and surveillance. Targeting radars, on the other hand, scan a much narrower area several times a second and are used for missile guidance systems and target tracking. But it's not all doom and gloom for the aircraft, however. There are a number of ways that a plane can reduce its radar profile to that of a small bird, or disappear altogether. But it's not as easy as you might think. A pilot can hug the ground to hide the plane in the natural relief of the terrain, but this makes flying much more dangerous. The shape of the plane can also be adjusted to scatter radio waves in any direction apart from back to the receiver, but this can seriously reduce the manoeuvrability and speed. However, there is another way. Unfortunately, it's not as simple as just changing the colour of the aircraft. The coating has to be totally redesigned on a molecular level. ONP Technologia is located in Obninsk. The company not only conducts research into composite materials and nano coatings, but also focuses on their real-life application in the aviation industry. Composite materials such as carbon fibre offer numerous benefits over those traditionally used in aircraft, and that's why the pakar is full of them. To make an aircraft out of carbon fibre, a mould must first be made. The company uses milling machines carefully to cut the mould out of wood. It is then finished by hand before being sent on to the next stage. Layers of fiberglass and carbon fibre are placed on the mould, which is then sealed in a vacuum bag. Tubes attached to the bag simultaneously suck out the air and infuse the mould with resin. The seal is constantly checked to make sure there are no imperfections in the finished product.
About 70 or 80% of the fighter jet's body is made of composite polymer materials, namely carbon fiber. We're now working on modifying the composite materials with carbon nanotubes, which will help further improve the durability of the components. At speeds of over 1,000 km per hour, metal wings start to deform, but CFRP ones don't, which allows the plane to move at higher speeds. Carbon fiber composite components also significantly decrease the visibility of the plane, making it a stealth aircraft. And Russia has been quite successful at applying the stealth technology.
As well as manufacturing composite aircraft components, the company also specialises in producing multifunctional nanocoatings. A number of institutes around Russia have been developing nanocoatings for aircraft canopies, but unfortunately they didn't meet the high standards required for the latest jets. The canopy of any combat aircraft must protect the pilot from electromagnetic radiation, the sun should not contribute to the plane's radar profile, and must of course be as transparent as possible. This lab has managed to develop one that meets all of these requirements. And it's applied in this special vacuum chamber. The canopy coating is made up of indium tin oxide and gold and is applied in a process known as sputtering. Layers of indium tin oxide and gold are applied in turns using an ionization process to build up a coating just 10 nanometers thick. But I'm afraid that's all we can say. The exact makeup of the coating is a secret.
Our coating makes the surface 40 to 60% less detectable by radar and 5 to 6 times more resistant to abrasion. This provides a huge advantage in the field. It is also much more transparent, which reduces reflection from inside the cockpit, enabling the pilot to see the runway lights more clearly.
Unfortunately, we weren't allowed to film how the coatings are applied to the other aircraft components either, but it isn't dissimilar to painting a large civil airliner. The coatings contain ferromagnetic nanoparticles, which are known for their radar-absorbent properties, but they aren't just applied evenly all over the plane. Different radar-absorbent coatings are applied to different parts of the plane in varying thicknesses. This attention to microscopic detail can give potentially huge benefits in the flight and stealth characteristics of the aircraft.
Russian designers say that while fourth-generation fighters using almost fifth-generation technology showed up on radar as objects the size of a football, the T-50 shows up on radar as an object the size of a tennis ball. So you can see the progress that we've made.
Once the composite components have been produced and the nanocoatings applied, their radar signature is tested in this anechoic, or echo-free, chamber at the Institute of Theoretical and Applied Electrodynamics here in Moscow. The chamber is completely covered in radar-absorbent material. The height of the sponge pyramids corresponds with the frequency of the electromagnetic radiation. The climate inside the chamber is controlled, and all the equipment is built on the same foundation to prevent any vibrations from affecting the readings. And this is how it works. The electromagnetic wave transceivers are located at the bottom of the chamber. The waves are directed towards the mirror, which converts them into plane waves, simulating the effect long distances have on radar signals. The radar behind this nose cone detects which signals are let through. The rest are scattered about the room, and some are reflected back to the mirror and picked up by the transceiver, which gives an indication of the nose's radar profile.
It's impossible to make the effective surface of a plane equal 0 and render it invisible. What is possible is to minimize the distance at which it is detected, and that's the aim of stealth technology.
The chamber is so sensitive that it can even measure the radar signature of a ball bearing with a diameter of just 1 millimeter. This is partly thanks to the giant parabolic mirror that has a precision of 30 millionths of a meter. The star shapes reflect any distorted waves hitting the edge of the mirror towards the walls to avoid any erroneous readings. The maiden flight of the pakfar's predecessor, the Su-27, took place 30 years ago, and the updated versions will still be in service in 30 years' time. So with such attention to detail and high technology going into the stealthy pakfar, I'm sure this isn't the last we'll see of it either. Or is it? With supersonic stealth fighter jets in the air, it may seem like anything on the ground doesn't stand a chance. But this next piece of equipment is a master of illusion, and may just even the odds. Military engagements are being carried out less and less on the battlefield and more on the electromagnetic spectrum. Rockets, jets and drones can devastate infrastructure, troops and fleets from hundreds of miles away because of their radar location systems. Denying the enemy use of radar while ensuring unimpeded friendly access to it can seriously improve air defense. Ship losses can be halved and aircraft losses can be reduced up to 6-fold. This is the role of the kasucha, the Russian word for the deadly nightshade plant, which has been used throughout history for its poisonous and hallucinogenic properties, and is a fitting name for this mobile radar jammer.
This is an upgraded version of the system, as it's capable of jamming complex radar signals, which is something we weren't able to do in the past. Also, it is so effective that one new system can replace 3 old ones.
The Kasucha 2 is manufactured by Kvant, which is part of radio electronic technologies. It works by receiving the enemy radar signal, processing it, and sending the exact same but much more powerful signal back to where it came from, all in a matter of milliseconds. This causes the enemy's radar screen to light up with noise, leaving them unable to lock onto the target. The radio frequencies of friendly forces can be programmed in as well, so they aren't affected. The Kasucha 2 also has other advantages over the previous models.
It works automatically. If you've noticed, it assumes the necessary position right away, and not just any position, using its stabilizers. The Kasucha also has a self-leveling system. Then the antenna starts working, and the station is fully functional and ready to detect targets.
The system is capable of hiding areas hundreds of kilometers squared and make it appear as if atomic power stations, ports, tank and troop columns never even existed. It can also use passive radar to triangulate the position of any bogies without giving away its own position. The Kasucha also has another trick up its sleeve. It can make false targets appear on the radar screen, which not only confuse the enemy, but also boosts friendly forces. With such an enigmatic ally on our side, these planes don't stand a chance. That's just the end of the first half, so don't take off. See you after the break. Welcome back. MAKS may have stolen the show this time, but let's take a quick look back at this month's other tech news.
News Bites.
Ministers from the 7 states participating in the ITER project met in France on the 6th of September. ITER, which is based around the Russian-invented tokamak, will be the world's largest experimental fusion facility and has the potential to solve the world's energy problems. During the meeting, the ministers reaffirmed the importance of and their dedication to the project. The Expo 1520 Railway exhibition was held for the 4th time earlier this month. The international event lets businesses demonstrate their latest trains, rail cars and engineering equipment to potential buyers. Among the highlights was a model of a next-generation metro, jointly designed by Siemens and Russian Machines. The metro is more comfortable, spacious, quieter, cheaper to run and easier to maintain than those currently in service, so hopefully it'll make my commute in the morning a little less stressful. Russian astrophysicists Vyacheslav Mukhanov and Alexei Starobinsky were awarded the Gruber Cosmology Prize for their contributions to inflationary theory by predicting the period before the Big Bang. The theory is an essential component for understanding the evolution and structure of the universe. It explains why the universe is so uniform and where galaxies come from.
Our theory gave a significant boost to radio astronomy. A number of different experiments followed, including the 1992 Cosmic Background Explorer Experiment, or COBE, for which George Smoot received the Nobel Prize. This experiment proved that the universe has irregularities of this nature.
In keeping with this month's aviation theme, we travelled to the quiet town of Chernogolovka to see a world where batteries last up to 5 times longer and scientists play with planes to make our lives greener.
What's up in the lab?
Autumn may already have come to Chernogolovka and the swifts are migrating south, but that doesn't mean that the scientists have gone into hibernation. In fact, their latest innovation is just about to take off here at the Institute of Problems of Chemical Physics. From the outside, it may look like we're a group of boys with their toys, but it's what's inside this plane that matters. This is the first plane in Russia to be powered solely by hydrogen fuel cells. It could fly for up to 90 minutes on a lithium polymer battery, which may not seem that bad. But now its insides have been replaced, it can stay in the air for almost 8 hours. As well as being able to fly longer, hydrogen fuel cells have other benefits over batteries or combustion engines. They are quieter, cooler, cleaner, and have a higher energy conversion rate. And compared to batteries, they are lighter and have a longer operating life. Hydrogen is an extremely green fuel as its only emission is water, and it can even be produced using energy from the sun. So having seen what it could do, I was keen to find out more. A lot of the research and development that went into creating the fuel cells was carried out in this lab. A fuel cell is like a cross between a battery and an engine. They generate electricity like a battery, but like an engine they require a fuel, which in this case is hydrogen. But where did the technology originate?
There were fuel cells produced which were used in space. Similar ones were used in submarines and are still in use to this very day. So the initial technology was finalized and completed in its current form between the 1970s and 1980s.
A basic hydrogen fuel cell consists of a proton exchange membrane, or electrolyte in the middle, a catalyst on either side, an anode and cathode, and 2 graphite flow field plates. Hydrogen flows on one side of the membrane and air on the other. The catalyst splits the hydrogen molecule into protons and electrons. The protons can pass through the membrane, but the electrons can't and have to pass through a circuit which generates electricity. On the other side of the membrane, the protons and electrons react with the oxygen from the air thanks to the other catalyst, which generates water and heat. These thin fuel cells can be stacked to produce as much power as necessary. I doubt the plane would get very far if they used the thick graphite plates used in hydrogen cars, so the Institute has managed to miniaturize the technology to such an extent that this block contains over 100 fuel cells. The flow fields that channel the gas are etched into thin sheets of carbon in this lab, and the finished fuel cells are tested in this machine. So why did they decide to stick them in unmanned aircraft?
Firstly, unmanned aircraft are aesthetically beautiful. Secondly, these devices are not very technically complicated, but they require extremely accurate weight and dimension parameters. The weight of this power source is one of its main benefits.
The Institute has 3 different drone models based around the same fuel cell system. The design of the aircraft is tailored to the role it must perform. One of them can even fly for up to 34 hours. This Ptero-E has been adapted to take 3D images of buildings and terrain. The fuel cells are perfectly suited to the long flights required to take the high-resolution images and do no damage to the environment. It can also be used to check for breaks in remote power lines and is currently monitoring the construction of the Winter Olympic facilities in Sochi.
An unmanned aircraft is a flying machine in which you can demonstrate that if this technology works, it can also be used in larger aviation, but not directly. All aircraft have an auxiliary power unit, which is used for ovens to heat the food, air conditioning, and a number of other flight functions. All the world's leading companies have their own hydrogen fuel cell projects. Boeing, Airbus, and our company is working with them on creating these power cells of a slightly different different scale.
Aside from aviation, fuel cells offer a greener, quieter and more reliable alternative to diesel backup generators. As well as being useful for those living in remote areas, it is of special interest to telecoms and intensive care units, where a reliable energy source can mean the difference between life and death. A German company is currently looking to localize production of this unit in Russia, which can generate up to 2 kilowatts of energy for up to 72 hours.
So we're using Western experience in Russian developments and implementing Russian developments in Western products. Hopefully what we do here with the Russian-developed membrane electronic units will return to the West as a finished product.
The only possible drawback of fuel cells is the use of compressed gas cylinders to store the hydrogen. But when Yuri explained that they only fill this super strong composite gas cylinder to just half its rating of 600 atmospheres, I no longer felt the need to run and duck for cover. I'm afraid that's it for this month's Aviation Special. But whether you're a frequent flyer or you prefer to keep your feet firmly planted on the ground, enjoy the ride.